Hey everybody, welcome to Video Notes 2.5. Guess what? Chemistry matters! Matters! Okay, so this is the one objective for this section. It's going to be a one and done celebration. So make sure you can classify matter and provide examples of each. So please read sections 3.3 and 3.4 in the book. Also section 3.5 talks about, well, now that we know what matter can be classified as, how can we separate it? Okay, and then make sure you can give an example for each of these things. All right, ready to learn? Sure we are. We're a cat and a monkey. Okay, so overall, matter can be classified a lot of ways. This way we're doing it based on what it's composed of. So you could have pure substances, and if you have a pure substance, it could be either an element or a compound. The thing about elements is that every atom is the same, okay? So this could also be an element, right? And it's just an element of two atoms of the same type bonded together. So elements have all of the same atoms. They could be bonded together, they could be individual. Compounds are two or more elements bonded together. So we're going to talk about bonds in the next couple of weeks, but the connection between these two atoms right here is called a chemical bond. So chemical bond. A compound has two different kinds of atoms. So there's an atom, and there's a different kind of atom. If a substance isn't pure, it's a mixture. And there are two kinds of mixtures. Mixtures where it's very, very well mixed, and each part of the mixture has equal proportions of each substance. And then there's heterogeneous mixtures where elements and compounds and other mixtures are mixed together and they're not very well mixed. Okay, well mixed, so well mixed that you can't see the individual parts, and not well mixed. But it's all about the composition. So we got to be looking at the parts that make it up. So atoms are the smallest pieces of matter, smallest particles of matter. And each element has its own kind of atom, which depends on protons. Molecules are atoms covalently bonded. And we'll learn what that means. Now, a molecule can be the same atoms bonded or two different atoms bonded. Okay, so it could be, so this is an element because the atoms are the same, and it's also a molecule. These are compounds because it's two different atoms and it's also a molecule. And this is atoms of an element. Pure substances, same. Every piece is the same. Every piece is the same. Compound, two or more elements chemically bonded. So something happened with their electrons so that they could have new properties than their elements. All of the same atoms. And there's about 118 known on PT. Okay. But about mixture, physical blend of different, let's see, elements, compounds, and other mixtures. Okay. Each piece keeps its own identity. This is and or. Okay. Homogeneous mixture is very well mixed. Well mixed blend, physical blend, and not well mixed. So you can see the individual parts. Okay, so this in a container would be a mixture because you have that kind of particle and that kind of particle, right? And then if you cut it in half, you see it's the same composition in each part of your mixture, so it's pretty well blended. That might be an example of homogeneous. Okay. So what particles make up pure substances? So make sure that you know atoms. So here's a definition. Smallest unit of matter has its own properties. The smallest part of an element is an atom. Many elements naturally exist as molecules instead of atoms. So this could be a representative of an atom. This could be a representative of a molecule, but it's the same element because it's the red one, not the blue one. Okay, so we're using models and pictures to represent. Okay, some molecules might have 3 pieces, but it's still an element because all 3 pieces are the red circles, the atoms of that molecule. 2 or more atoms covalently bonded. Smallest unit of many covalent bonded compounds are molecules, and also a molecule can be an element too. All right, formula unit is a technical term for a different kind of compound, ionic compound, and so that's when you have a metal and a non-metal sharing or transferring electrons, and they make the charged particles. Okay, so it's ions bonded together. All right, it's called a formula unit. Molecule, atom, or formula unit, element, or compound. Okay, so you look at it and you say, all right, here's an Na plus and here's a Cl minus. Those are ions. If ions make up the structure, then it's called a formula unit, this whole thing. So this is a compound because it has 2 different kinds of pieces that come together to make the whole piece, and that whole piece is called a formula unit. This is an atom, and so it must be an element because it's all the same. So there's this atom, this atom, this atom. Oh, sorry, those are the same. So the gray one, the white one, and the red one. Chemical bond, chemical bond. This is a compound. Right? But it's a compound made up of molecules. So this whole thing is one big stinking molecule, all chemically bonded. Okay? This is a molecule. So there's more than one atom, chemically bonded, chemical bond. And it's an element because all of the atoms are the same. This is an element, and there's molecules, and an atom. But it's all an element because it's same. Blue, 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 same. Okay. Pure substance or mixture. All right, so we look at this piece, every piece is the same, so this is pure. Pure substance or mixture. Well, we got the blue things and we got the red things, so this is a mixture. And then this has chemical bonds, so this is a molecule of an element in our mixture. This is an atom of a different element in our mixture. So all of this together is a mixture of molecules and atoms and a mixture of elements. This is pure, and these are molecules of a compound. Why is it a compound? Because there's a chemical bond between the black atom and the red atom. Okay. So, pure substances or mixtures. A pure substance, every particle, I'm going back, is exactly the same. So this has all of the same properties. Every part of this pure substance has properties associated with it. This part has different properties than that part. Okay. So you can use physical properties to decide if a substance is a pure substance or a mixture. Right. This looks like salt water. Okay. So salt water. If you look at salt water, it looks pretty same all the way through. Okay. So it looks all the same. But if you think about it, there's salts and water. Water stays water, has its own properties. Salt stays salt, still tastes salty in salt water. So this is a mixture. And in a mixture, it's a physical blend, so each piece keeps identity. Each piece keeps its identity. Table salt. Okay, so you got Na and Cl, so there's a chemical formula for it. But the Na gave its electron to the Cl, so it's Na plus and Cl minus. So it's no longer sodium, the metal, that when you put it into water, it pops and explodes. It's no longer chlorine, the element that when you breathe it in, you could make you really sick. Once they chemically bond, chemical bond is the transfer of electrons is a chemical bond. So this is a compound. And that compound is pure because all parts of that compound have the same properties. Okay, water, H2O. It's a chemical formula. It's not the gas hydrogen. It's not the gas oxygen. It's a chemical bond. Chemical bond. And so it has unique properties, unique props, and it's a pure substance. Okay, oxygen is an element, and it's O2, so it's made up of molecules, but it's a pure substance that's an element. Air, we got some oxygen, you got some nitrogen, you got other gases, but the oxygen is the stuff that helps us breathe. The nitrogen doesn't react, it's non-reactive pretty much in the air. So this is a mixture because each piece keeps its own identity, and it's homogeneous because it's really well mixed. This one is also homogeneous because salt water is so well mixed that you get the same proportions of each part, salt and water in it. Okay, homogeneous or heterogeneous. Okay, we'll talk about this one in class, but I want you to think about it. So classifying matter asks the questions: what are the parts? What are the props? What are the properties? What is it made of? Right? What are properties? Can it be separated? Are there chemical bonds? So those are the kinds of things you got to think about. Okay. All right. So to review, make sure you know that elements and compounds are pure substances because each piece is the same. Mixtures are physical blends of compounds, elements, and other mixtures. Compounds are chemically bonded atoms of different elements, and that elements can be made of atoms or molecules, but all of the atoms are the same. Okay. Make sure you do this. I also suggest section 3.5 so you can find out how to separate them. Peace out. Make sure this is the one thing you got to focus on. You can do it. See you soon.